Hello, my name is Jonathan Rumley. I'm a postdoc in Oliver Hobart's lab at Columbia University. Today I will walk you through the installation of TargetOrtho2 on Windows systems via Windows Subsystem for Linux, or WSL. The same instructions will apply to the installation of TargetOrtho2 on Ubuntu systems as well, except that they will not require WSL. I will also discuss how to use TargetOrtho2. To start out, let me give some background on TargetOrtho2. TargetOrtho2 is a program that predicts transcription factor target genes using a phylogenetic footprinting-based method. It was developed by Lori Glenwinkle, a former Ph.D. student in Professor Hobart's lab. It was originally published in the article In Silico Analysis of the Transcriptional Regulatory Logic of Neuronal Identity Specification Throughout the C. elegans Nervous System by Glenwinkle et al., 2021. A link to this article is provided in the description below this video. TargetOrtho2 takes as input position-specific scoring matrices, or PSSMs, in MEME format. We provide 3 examples of PSSMs in the TargetOrtho2 download, and many others can be found in motif databases from the MEME suite download site. Also, PSSMs in other formats can be converted to MEME format. TargetOrtho2 uses the MEME suite program FEMO to search the genomes of 8 nematode species for sites that match the input motif. TargetOrtho2 then uses genome annotation data to assign these sites to the upstream regions, introns, exons, and downstream regions of protein coding genes in each of these genomes. TargetOrtho2 then predicts transcription factor target genes in the reference genome, by default C. elegans, using a Gaussian process classifier from the Python module scikit-learn. The Gaussian process classifier compares the motif features for each of the genes in the reference genome that has predicted binding sites to motif features in experimentally confirmed targets and non-targets of 3 transcription factors. The most important feature is the alignment-independent conservation of predicted sites in upstream regions and introns. TargetOrtho2 was originally provided as a Galaxy web tool, but this version is no longer available. Because of this, I have written a protocol for the local installation and use of TargetOrtho2, which is now published in the journal Star Protocols. This protocol describes the installation of TargetOrtho2 on macOS and Linux systems, as well as Windows systems via Windows Subsystem for Linux, or WSL. Also, since the original version of TargetOrtho2 was written in Python 2 code, which is now deprecated, I have converted the code to Python 3, which allows the use of the latest versions of Python modules. The protocol provides instructions for installing this new version of TargetOrtho2. Additionally, the protocol provides instructions for updating the genomes in and adding new genomes to TargetOrtho2. In this video, I will walk you through the local installation of TargetOrtho2 on Windows systems via WSL, as well as how to use TargetOrtho2 to predict transcription factor target sites and target genes. Let me share my screen. Okay, to start out, I will open Command Prompt in administrator mode. So go to the Start menu, search Command Prompt. Let's see. Wait a minute. Search command prompt. Right click. Okay, yeah. Run as administrator. Uh, yes. Okay. Okay. Next, I will enter the command WSL -- install. Let me increase the text. Okay. So yeah, the command is in this line here, WSL -- install. Okay. Next, I'll enter the command WSL -- list -- online. Okay. And this gives me a list of the available distributions. Let's see. Okay, I'll go with Ubuntu 24.04. So for that, I'll enter WSL -- install -d Ubuntu 24.04. Okay. Okay. Let's see. Now I can close command prompt. Let's see. Okay. I can open Ubuntu. Hmm. Installed. I ran into an error here because the computer that I was using did not have virtualization enabled. To enable virtualization on your computer, follow the instructions on the Enable Virtualization on Windows website, link in the description, and follow the instructions for your computer's manufacturer. Now that virtualization has been enabled for the computer, Ubuntu has been installed properly in WSL. To install Python 3, enter this command in the WSL window. Sudo apt install Python 3. Enter your password if asked. To install scikit-learn module, enter these commands in the WSL window. Oh, that was the command for installing in Mac. Sorry, enter this command, sudo apt-get update. Now enter this command. Say yes. Enter this command to install the pandas module. Say yes. Now you want to install the meme suite. To install the meme suite, go to the meme suite download site and download the latest version of meme suite. As of the recording of this video, that's MEME 5.5.7. And to navigate to the downloads directory, slash int slash C in the case for this computer, slash users, slash HarborLab for this computer, slash downloads. Meme suite compressed file is in the downloads directory. You extract the meme suite by entering this command. Now that compressed file has been extracted, and we have the MEME-5.5.7 directory, the downloads directory. Now, you should install several programs that are required to install the meme suite properly, such as Bit Essential, which is a set of developer tools, also zlib1 g-dev. Autoconf, automake, libtool, now you want to navigate to the MEME 5.5.7 directory and enter these commands. Now enter sudo make. You want to run the command sudo make test. It looks like the programs that I need, particularly Fimo, should have been installed correctly. Enter sudo make install. I'm going to go back to the home directory. Open the file .bashrc and add this line to the .bashrc file. This line here that begins with export. Control O to save, Control X to exit. Now you want to copy the meme suite program FEMO to the directory /user/local/bin. So I'm going to navigate to the meme directory, which is in the home directory. Should be in bin. And yes, FEMO is in the bin directory. Now you want to enter this command to copy it to the /user/local/bin directory. Sudo cp femo /user/local/bin. And now I'll check to make sure that it's in this directory by navigating to the directory. And it is. It was correctly copied to the /user/local/bin directory. Now I'll return to the home directory. Now I'll install BedOps by downloading the BedOps binary files for Linux. I'm going to go to the BedOps website. I'll download the BedOps binary files for Linux. It goes in downloads. Fortunately, you can't extract it this way. Now I'll cancel. I'll go to the downloads directory. find the BedOps compressed file. Trying this command to extract the file. Unfortunately, this is not the right command. So this does not work. You have to enter this command, actually, to extract the file. So entering the version. Okay, and now the file is being extracted properly. So yes, this is the command you want to enter. Sudo tar jxvf, then the name of the compressed file. Now you want to copy the BedOps binary files to /user/local/bin by entering this command in the WSL window. Sudo cp bin /star/user/local/bin. Now I want to go to the /user/local/bin directory to confirm that these files have been copied, which they have. Now I'll return to the home directory. Now I'll install bed tools by entering this command in the WSL terminal. Sudo apt-get install bed tools. Now I have installed the suite of programs required for TargetOrtho2. I will now download TargetOrtho2 itself from TargetOrtho2 Python 3 GitHub repository. I'll go to the TargetOrtho2 Python 3 GitHub repository site. There it is. I'll click the green code button to download the zip file. And I'll extract this file, move it to the desktop. In the TargetOrtho2 folder, I have provided 3 options for running TargetOrtho2. TargetOrtho2 Python 3 GitHub uses the WBPS 10 versions of the genomes of the 8 species included in the original version of TargetOrtho2. TargetOrtho2 WBPS 19 uses the WBPS 19 versions of the 8 species genomes. TargetOrtho2 WBPS 19 plus CTROP uses the WBPS 19 versions of the 8 species genomes plus a new version of the C. tropicalis genome produced by Toker et al. 2024. For this video, I will use the TargetOrtho2 WBPS plus CTROP version. I will decompress all of the files in this folder, and this folder must be organized as they are in the TargetOrtho2 Python 3 GitHub directory, which I will demonstrate. And you can put the TargetOrtho2 directory, TargetOrtho2 Python 3-main, in whatever location you want, but for this video, I've put it on the desktop. Okay, so in WSL, I am navigating to the TargetOrtho2 folder, TargetOrtho2 Python 3-main. And here's a list of all the files and directories within this directory. I'll navigate to the TargetOrtho2 WBPS 19 plus CTROP directory, and I'll extract each of these files. So unzip the Cinorhabditis tropicalis genome. Looks like the unzip command is not found, so I'll install it using sudo apt install unzip. Okay, now the unzip command is installed. So now I will unzip the C. tropicalis genome. Now that's done. Now I'll unzip the TargetOrtho2 WPBS plus CTROP. The other two files. Now I'll unzip the other files, zip file. Now I'll go into the TargetOrtho2 WBPS 19 plus CTROP folder and arrange the folders as they need to be. Okay. Need to move these two folders to the parent directory of this one. Need to open a new tab. Okay. Now I'll move these two folders to its parent folder. Now go to this other file. Move these files and folders to their parent folder. We need to open the parent folder. And mistake here. Need to open the parent folder again. Okay. Now I'll move these files to the parent folder. Okay. And I'll move the C-Tropicalis genome to the genomes folder. There it is there. Okay. Now I'm going to download the other genomes from Parasite. By running the setup.command Python script, entering this command, python3 setup.command. Now it's downloading the genomes. And putting them in the genomes directory. You can see here, now it's extracting them. Okay, now that's finished. Okay, now TargetOrtho2 is ready to be run. I will run TargetOrtho2 using the COE motif as input, which is provided as one of the example motifs. And so I'm going to enter this command. In order to include C. tropicalis in the analysis, I do need to include a species list, which I have included in a list I have included a list of all 9 species in the file, allspecies.txt in the species list directory. So here I'm using the file, using entering -f, using the file data slash input motif examples slash COE motif PSSM MEME-format.txt. Unfortunately, tab does not autocomplete this file name. So yeah, I'm entering the p-value threshold of 0.0001 as an example. However, this actually is the default p-value threshold, but I'm showing you how to enter it as an example. So now here I'm including the species list, entering -s, and the location of the species list, which is in species lists. This directory here. The file name is allspecies.txt. Okay, looks like everything is correct in this command, and I'll run it. If you see this output, that means that FEMO is working from the TargetOrtho.py script. And now, while the program is running, I'll show you where to find the MEME-format PSSMs from the MEME suite and how to convert PSSMs that are not in MEME format into MEME format. So there's a collection of MEME motif formatted motifs in the motif databases on the MEME suite website. You can see here there are several collections. I'll go into SysBP 2.00. You can find your species of interest, including C. elegans, Cinerovidius elegans, .meme. I'll open it in Notepad. Let me increase the font size. Okay. To create a new MEME-formatted motif file, you can copy and paste the top portion of this file into a new text file. And you can search for your motif of interest, say POP1, and find your motif of interest and copy the motif name as well as the PSSM associated with it. Copy and paste that to the new file as well. Okay, and just save this file. Call it POP1 SysBP 2.00 motif. This is what the COE motif file that I'm using to run TargetOrtho2 looks like. This is a log odds matrix. The other one is a letter probability matrix. TargetOrtho2 will accept either type of matrix. Okay, this is a SysBP format matrix. This is a raw counts matrix. You can convert either of these type of matrices to MEME format using either a program included in the TargetOrtho2 download or the matrix to MEME program included in the MEME suite. For the SysBP formatted PSSMs, you use the execute copy terminal.py script included in the TargetOrtho2 download, and for raw count matrix, you use matrix to MEME from the MEME suite to convert it to MEME format PSSM. me open a new Ubuntu window to show you how to run these programs. Increase the font size. Okay. Now navigate to the directory that has these example PSSMs for the video. And the sysbp format PSSMs actually have to be in a directory to run execute copy terminal.py on them. And it can convert an entire directory full of sysbp formatted PSSMs to MEME format. So I'll make a new directory to put the sysbp formatted PSSM into, call it sysbp PSSM. Now move the file into there. Yep, now you can see the file is in this directory. Now go to the TargetOrtho2, Python 3 main directory, and the TargetOrtho2 WPBS 19 plus ctrl directory. Now run the program execute copy terminal.py by entering this command. Now run this program. On the directory that contains the sysbp format PSSM. This will be my input directory, and now I'll name an output directory. Call it MEME PSSM output. Okay, program's been run. As you can see here, the way I've run it, that directory is not here. Actually in the TargetOrtho directory. See, here's that directory, MEME PSSM output. is the output file, is the motif in meme format, open it in Notepad, and this is what that motif looks like now in meme format. So if I want to put the new directory in the same directory as I'm taking the input directory from, then I'll add that directory to the beginning of this directory's name. Okay. Now that it's run again, and so now the new output directory is in the example PSSMs for TargetOrtho2 video directory. And there's the output file. And here it is again. Okay. Now, here's the raw count matrix. You can convert a raw count matrix to a meme format PSSM using the matrix to meme program from the meme suite. I'll navigate to the home directory and navigate to meme. Navigating to the bin directory, but it's not actually in there. It says it's not actually in this directory. See, and it's not one of the files listed in this directory. It's actually in this directory here. And you see find matrix to meme, it's here. So now I'll copy matrix to meme to the /user/local/bin directory by entering this command, sudo cp matrix to meme /user/local/bin. I'll navigate to the /user/local/bin directory to confirm that it's there. And it is. Now navigate to the example motif directory, where the example motifs are for this video. And I'll run matrix to meme on the raw count matrix file. So yeah, enter matrix to meme as the program name, less than sign, to the file name, two greater than signs, and the name of the new MEME-format PSSM file that you want to make. Okay, and here's that file. Okay, and this is what this file looks like. Okay, so now TargetOrtho2 has run properly, found several matches in all of the genomes for the input COE motif, and it processed all of the genes in their orthologs for sites that match the motif. As well as conservation among species. Okay, and you'll find the results in the folder beginning with the job ID. To look at the motif results, you go into the motif match data per species file. I'll look at the file for the C. elegans motifs. I'll increase the size to make it easier to see. There we go. I'll look for the results for the gene ZIG1. Here we go. There was one site identified in the upstream region of ZIG1 and one in an intron of ZIG1. Now, fortunately, the number of results that I got from this analysis was fairly manageable, and the spreadsheet program Microsoft Excel was able to open the file. You can use any spreadsheet program to open the file. If you set the p-value threshold pretty high, in other words, set it with weak stringency, then you may end up with a very large file with potentially millions of entries, which will be too big for a spreadsheet program to open. So for that case, we have included an R script called TargetOrtho motif match motif search terminal.r, which will allow you to filter the results on the gene that you're interested in, and in order to use this program, you have to install R, which I'm doing right now in the video. So now R is installed. I will attempt to run the R script now. Use this command. Need to include the location of the script, which is in the grandparent directory of this one. 2 directories up. Okay, enter the file name. CLA. And I'll enter the gene of interest, say ZIG1. Fortunately, the package reader is not installed, so I have to install that. Okay, so now open R, using the r-vanilla command, and I'll just go ahead and install both of these packages, one of which is reader, and say yes, and say yes. And you can choose any crayon mirror. I'm going to choose one of the US ones. In this case, Ohio. Okay, now readers installed. I'm going to exit from R, which I'll find out involves entering Q parentheses. Okay, yes, and this is how you close R. Now I'll try running the R script again, but dplyr is not installed, so I'll need to install that. I'll do that by entering this command, entering R again. And running the install command again. Have to put quotes around dplyr. So I'll do that. Now I'll select the same crayon mirror again. Now that's done. I'll quit, and I'll try running the R script again. Janitor is not installed, so I will install Janitor. Open R again. And I will correct the command and install Janitor. One more time. There we go. Select the same crayon mirror. Okay, now the installation is complete. So I'll quit R. Now I will run the R script again. And now it worked. Okay, now let me show you the results from filtering the results from the C. elegans motif match results. Let's see, the file name ends with filtered. You can open it in a spreadsheet program such as Microsoft Excel. And this only shows the results for Zig1 now. Let me make the font bigger so you can see it more easily. See, now it shows only the one upstream and the one intron site detected for Zig1. And this is very useful, as I said, if you have very large motif files that may have more than 1 million entries. So now let me show you the target gene results file. It's in the main results folder. It ends with ranked gene summary. This has a ranked list of all of the genes in the C. elegans genome, or if you use a different reference species, that reference species genome that had sites detected, and it ranks them by class label probability or class prob, as you'll see on here. See, the top ranked gene is MCU1. Yep. So the classifier label probability ranges from -1 to +1. Positive class probabilities indicate a probable true target. Negative classifier label probabilities indicate a probable true non-target. And it shows the number of species in which there is a conserved COE motif in the upstream region of this gene and its orthologs. And in the next column, the number of species in which there's at least one conserved site in any of the introns. And remember, these aren't sequence aligned, so the conservation in introns indicates that there is at least one site in any of the introns for this gene's ortholog. And there's more species-specific data to the right of the summary data. And so, say you want to look up specific genes such as ZIG1, you can use the find function, and it shows that since the classifier label probability is a positive value, then it is likely to be a true target. It's conserved in its site. The COE sites are conserved in 8 species in the upstream region and 6 species in introns. And now this brings us to the end of the video. As I said earlier, the protocol also includes instructions on updating and adding new genomes to TargetOrtho2, but I will not discuss that in this video. Thank you for following along with me in this video. I hope you found it helpful. If you have any questions, please send them to me at jdr2203@columbia.edu. Have a good day.